There we go. Now, start presentation, and let me see if I can find, if I could get the dang mouse to work. Dang Russians. Must have a Russian mouse. There we go. Now I can draw one. Y'all are impressed, aren't you? All right, so we got fundamentals. We went through that. Parameters, statistic. Go through that. Population sample. Go through the examples. I'm not going to go through that. Simple, random, systematic, convenient, stratified. Did that. I'm stopping whenever I get the margin of error. Bias. We talked about bias and how a good representation of non-bias is a judge or a referee. Okay? Observational study, we talked about that. Looking at people. Sounds kind of perverted, but that's when you watch people. And experiment is when you interject something into the observation, it becomes an experiment. We talked about that. I don't get into that too much. Placebo, we talked about that, didn't we? Mm-hmm. Okay. Placebo effect, somebody thinking something's wrong with them, and a pill that doesn't mean anything fixes the problem. I didn't go through double blind, single blind, because I don't think you need to know that. Okay, retrospective is when you go back and study records of things that happened in the past and bring statistics from an old survey.
It was there in that sermon.
Still trying to get there. Bear with me.
I have a question.
Double blind and single blind or something like that.
Yeah, we're not doing that. It shouldn't be in your homework. If it is, I'll take it out. But let me know if it's in your homework and I'll take it out. Okay. Margin of error. Just let me know after class. Okay. I'm doing one thing at a time. I'm a male. Y'all know I can't do two things at a time. Y'all females know that. So I'm gonna have to address the margin of error first. Then we'll talk about the homework. Okay. Miss Riddle, remind me to do that. Okay. All right. Okay. Margin of error. Now let me show you what the margin of error is like. Okay. Later on, well, in 120, you actually calculate the margin of error. But I don't think we calculate it in 103. But the margin of error, where did my whiteboard go?
You see why?
Away.
Cannot see this now. You see?
It's going to be one of those days.
They're about to write something on the board. We cannot.
It's going to be one of those days. I can already tell. Hold on a second, y'all. For some reason, it just decided to go out. New. There. And I pull up the handy dandy. This mouse is not working correctly. And presentation, use primary. Primary monitor. There. That's what it's supposed to do. Now I got to go back, backspace, backspace. There we go. Okay, if I ask you to give me an estimate, let's say that Miss Riddle, and I can remember her name more than anybody's. Miss Riddle is a interior designer, okay? And I asked Miss Riddle to redo my den, okay? Redo my den. Make it look all pretty, okay? And she comes in and she looks at the den and she says, oh my God, this is going to take 2 or 3 months, okay? She looks at the den and she goes, okay, it's going to be about $5,000, give or take $1,000. She just gave me a what? An estimate. And she said $5,000 plus or minus what? 1,000. So that means that the low end of my den being redone is what? 4,000. She gave me the quote of 5,000, and the high end is what? So So somebody tell me, what did I do on the right side of the 5,000? Did I add or did I subtract?
Subtract.
I subtract. No, right side. What did I do on the right side of 5,000?
Right, you add.
I added because that. Okay, for some reason it's not supposed to be doing this. Okay, on the right side, whenever you go, think of it as a number line. Okay, this thing's not going to work today. It's only going to work on the slides that I don't want it to work on. Now I'm getting irritated. Okay, I'm going to try it one more time. I'm going to hit the button 3 or 4 times. Pen, 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 pen. Okay, any kind of number line to the right, let's say this is 0 on a number line. Anything you do to the right of 0, what do? You add, right? Anything you do to the left of 0, you what? Subtract. And you've got to remember that. Okay? So I'm going to go up here and I'm going to put a number line and I'm going to put a 0 right here and I'm going to put subtract on the left and add on the right. Now you're going to do this with estimates. You're going to do it with, I'm going to put estimates. You're going to do it with margin of error. And you're going to do it with standard deviation. So you need to get used to doing it. So let's look at it. $500, I add $100, that gives me $1,000, that gives me 6,000. I subtract $1,000, that gives me 4,000. So let's say that Miss Riddle does the job and she gets her time and she adds up her time and her expenses and everything, and she says it's going to be right around $4,500. What am I going to say? Great. And that's one scenario. One scenario is Miss Riddle says, well, if I got your bill and your bill is $5,600, I'm going to say, great. But let's say that Miss Riddle has got substance abuse and she comes to me with a bill of $6,500. Then I'm going to have a what? A problem. Why? Because she's gone over the estimate. Okay? Now, margin of error is the same way. Let's erase this board and it'll probably have a connection. Let's say that I have P. I'm just going to use P as an example. P is equal to 57%. I don't know why this is blinking. Let me see if the other one battery's better. Let me try the other cursor. I meant the other, whatever you call this thing, stylus. Let's say that P is equal to 57%. It can be anything. It can be 25%. It can be 32%. And I give you a margin of error of 3%. Then you go down here and you say, okay, 57, that's the estimate. And then what do I do to the right of the estimate?
You're adding 3.
Add 3. And that'll be 60. What do I do to the left of the measurement? And that'll be what? So the area, the parameters are 54% to what? 60%. And that's what margin of error is.
In the assignment, I found out that the addition comes twice.
Yeah, you can do it twice. You can do it 3 times. It depends on what the question asks.
Okay, double the
yeah, so I can add 3 again, it'd be 63%. I can subtract 3 again, it would be 51%. It depends on it depends on what they ask for.
Okay.
Okay, let's see what they give us as far as a question. Let's see what they put on the slide here. Maybe it'll help you. Okay, so on the right of subtract, you what? I mean on the left, you what? Subtract. On the right, you what? Add. And that's what they're basically telling you. All right, look at this question. Now, I'm not going to test you on margin of error, but let's see what they give you. It says an election eve poll finds that 52% of surveyed voters plan to vote for Smith, and she needs a majority, more than 50%, to win without a runoff. The margin of error of the poll is 3 percentage points. Will she win? Well, you put 52 in the what? In the middle. So I don't like to write in red, so I'm going to write in black.
Okay.
52% in the middle. Did I use 52% in that previous problem? Okay. I was fixing to say that would have been weird. Okay. So 52% plus what? What's the margin of error?
Plus 3.
So what's 52 plus 3? 55%. What's 52 minus 3?
40.
Will she win?
Yeah.
Pretty much, she's got a good chance of winning. Why? Because her percentage points, as far as a runoff, is where? Right there. So wouldn't you say that she's much more in favor to win than not win? Because this is not winning for a runoff, okay? Here is not winning. And this is over 50%. So which is in her favor? Winning is in her favor, but there is a chance. I would say what? A 10% chance, maybe, that she's not going to win, because this represents, that red area represents about 10%, 8%, 11%, a small part of this whole thing. So I don't know what the answer is, but we'll see. There's a small percentage that she won't win, or will have to have a runoff. Look at there, 55%. We can be 95. They're giving it 95% confident, because I said 10%. They're saying 5%. But the whole point of it is, I want you to be able to see that chances are she's not going to have a runoff, because that 10% represents a runoff. Okay, we can be 95% confident, blah, blah, blah. It's between 49 and 55%, because the confidence interval leaves open the possibility, and that's the red, of either a majority or less than a majority. This election is too close to call. Okay? I'd go against that a little bit. In real life, chances are she's not going to have a runoff. But it is a close election because of the beginning. What's the election poll find? What does it find? 52% of surveyed voters plan to vote for Smith. Anytime you have a poll saying 50-something%, yes, the election is going to be close. But the question says, the margin of error, blah, 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 will this end in a runoff? And I say no, because you only got 10% being around 50. The rest of it's going to be more than 50, and that's what she needs to have a runoff, not to have a runoff. So, yes, the election is close to call. Why is the election close to call? Because she has what percent? She has 52%. And any election that has around 50% is going to be close to call. But the question asks, and she needs a majority, the 50% or more, to win without a what? Without a runoff. And I'm telling you that the odds look pretty good for her not to have a runoff, because 90 to 95% of her margin of error is in the green. So I would say that she probably is going to win the election. So that's how you basically set up an upper bound, and you set up a what? A lower bound. That's what you do with margin of error. Upper bound is 55%. Lower bound is what? 49%. Does that help?
Yes.
Okay. That's the only thing I'm going to ask you to do with margin of error. Set up upper bound and a lower bound. Okay, let's get out of that. Let's see what else is after that. That's the end. Okay, so that was the last thing. Was that the last thing we went over?
No.
What was the last thing we went over? We were in frequency distribution, frequency table. So let me go. What section was that? 5C. Okay, let's go to 5C. Sometimes I like to use these. I don't use them very often, but I like to use them because they go through the section and I don't forget something. So, because they're already done. So, okay. Let me go to slideshow and from current slide, statistical reasoning, frequency table. We've already talked about that. Let me know where I need to stop. What was the last thing we covered?
I've seen frequency table, right? Relative frequency.
We started on graphs. We started on the histograms and paragraphs.
Okay. I told you relative frequency was a 25-cent word for percentage. We talked about qualitative, blondes, brunettes, and redheads. And quantitative means numbers. What about your social security number, your zip code, and your area code? Is that qualitative data or quantitative?
It's qualitative.
Qualitative, because there's no mathematical reasoning for a zip code. There's no mathematical point to a social security number. There's no mathematical operation for a zip code. Can you add zip codes and get another zip code? No. So there's no mathematical operation. If there's no mathematical operation with the numbers, then it's qualitative data. Anything else, if it measures something, that's mathematical. If you add it, that's mathematical. If you average it, that's mathematical. But you can't average social security numbers. And you can't average zip codes. And you can't average area codes. Capiche? Phone numbers. You can't average phone numbers. Okay? There's two examples of qualitative and quantitative data. Brand names of shoes, heights of students. And you could add to that. Qualitative, blondes, brunettes, redheads. Sandals versus no sandals. Brown eyes versus blue eyes. Any of that kind of stuff. Category. Okay? Category. Put category under qualitative. And what goes under quantitative? Classes. Okay, this is now we can do this. Consider the following 20 scores from a 100-point exam. Blah, 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 blah. Determine appropriate bins and make a frequency table including columns for relative and blah, blah, blah. Okay, first of all, you put them in what?
Category.
You put them in order. That's the first thing. So put them in order. Now, I can't make this bigger, but it's pretty decent size, so you should be able to see it. Unless you're sitting in like BFE in the back of the room. And if you can't see it and you're sitting in the back of the room, then what's the solution to that problem? Get your butt up and move if you can't see it. All right, so here we go. Y'all have to help me here. I see a couple of 72s. I see 3 72s. Is that the lowest number? Okay, I got one person interacting with me. I appreciate your interaction. The rest of y'all just sitting there, so thank you for y'all just sitting there. I appreciate y'all's non-interaction.
There's 174.
Okay, 74.
Or 275s.
275s. Let me erase them. 74. 75. What's next? 76. 276s. Y'all settle down, Oconee and Easley. Settle down. $177.
178.
178. I see an 80, but is there a 79? 79. 180. One. What else? I'm looking for 82. I don't see 82. 83. I see 84. 84. 86. I don't see but 186.
Yeah, there's 186.
Oh, okay.
88 and 88.
Okay.
I heard somebody mumble. Thank you. Appreciate it.
91.
91. Thank you, ma'am. 91.
94.
A 94. 98. Anything else? Now, of course, y'all know these are like test scores, so y'all know what the classes are. 0 to 59. 60 to what? 69. 70 to what? 79. 80 to 89. 90 to what? 100 or 99. Doesn't matter. So you got classes. Why are they classes? Because they're grades, aren't they? Yeah. They're grades. I'm sorry, what?
They have them broke up really weird in the book.
Well, that's stupid, because why would you break them up? They're test scores.
Yeah,
they don't give you in this problem, this is not the same problem as that in the book, is it? Mm-hmm. Well, they don't give us anything. They don't give us anything to go by. They say determine what? Appropriate. Now, I'm sorry, but I don't know how appropriate it is. I'm 52 years old, and I've never seen a grade that was outside of 90 to 99 be an A. Have y'all? Besides those stupid scales that they used to try to make the grades better, and it didn't work. What they used to do, 93 to 98 or something like that, that didn't work.
I don't understand why they did that.
They did it to try to make the grades better, and it wasn't. They tried something and it didn't work. Instead of addressing the problem. Addressing the problem was that students wasn't learning because they wasn't studying and the teachers wasn't teaching. Well, basically a combination of the two. But anyway, 90 to 99 is the only thing I ever knew about. So we're going to go with that. I care less what the book says. So, how many we got from 90 to 99? Let's see. 90 to 99, how many? 3. 80 to 89. How many is that? 1, 6. 70 to 79. 70 to 79 is what?
11. I think.
11. That should be it. Nobody failed. Nobody made a D. That ain't happening. All right. So basically, if you wanted to do a cumulative, first of all, you need to add these scores up. What's 11 plus 9?
20.
20, Hubert. Yes, because the n is 20. So n is equal to 20. The total is equal to 20. So if you wanted a relative frequency, which means percentage, relative means percentage, that would be 3 over 20, 6 over 20, 11 over 20. I'll do these two for you. 0 over 20 and 0 over 20. I'll do those two. 0%, 0%. And you do these. And you just do the calculator. 3 divided by 20. Well, that's 0.015. Somebody check that. Or 1.5%. I don't know. Something like that. Huh?
0.5.
Huh?
15%.
It's 15%. Okay. And 6 divided by 20, it'd be 30%.
Yes.
And 11 divided by 20 is going to be 65% or 55%. And that's your relative frequency. Now, the cumulative frequency is pretty useless, but I'll show you how to do it. You take the first number and you put it right here. And then you add the second number, 9. And then you add the third number, 20. Plus 0 is what? And these two are supposed to match. Cumulative frequency is more of a check than it is anything, but it's not really worth anything. And that's how you do that problem. The first thing you do is you put the data in what?
In order.
And after you put it in order, then you find your classes. Now in this case, I picked the only class that there was. Because somebody tell me, I'll give you $1. Tell me in these directions what tells you which kind of frequency, which kind of class to use. Do they say a class of 5? Do they say a class of 8? Do they say a class of 2? Or do they just leave it open and say determine appropriate? So I don't know what that book has. If the directions match these directions, there's no way, huh?
It does. It's just like broken up into 95 to 99, which I think is stupid.
Yeah, the directions don't say do that. Appropriate to me is a base 10 scale of grades. If it said consider the following 20 scores on a 5-point scale, then that would be grounds to make it 95 to 99, 90 to 94, and so on. But they don't say that. So I went with the 10-point scale. Who's got a question on that one? Make sure you can find the relative frequency and the cumulative frequency because that is on the test. 1 or 2 questions on the test. And if you can't do it, just consider yourself a failure. Vodka and cranberry juice. Breakfast of champions. That's a joke. I don't drink, okay? Not often. All right. Are y'all awake or are y'all just not talking to me? Did I say something to offend y'all or something?
I'm dead on the inside.
Okay, you're dead on the inside. Okay, that's nice. Okay. Why are you dead on the inside?
It's just
bad
one of those
week,
days.
bad day?
Bad week.
Well, I know how that feels. Believe you me, I know how that feels. And after you find the classes, you find the total, number 3, find the total, and then you find the relative frequency and the cumulative frequency, which the relative frequency is just a 25-cent word for percentage. Okay, so we feel good about that?
Yes.
Now I want somebody to tell me where they got those classes from. Tell me in those directions where they got a 5-point scale. I don't know. So if you do one like that and you get it wrong, you might want to try a 5-point scale because evidently whoever wrote this book grew up in a town that had a 5-point scale. Because I never heard of it until they tried to do that here with the elementary schools here in Anderson a couple of years back. And it lasted about 5 or 6 years and then they quit doing it. What was an A?
It was 93 to 100 was an A.
Yeah.
And I think it was an 80. It was an 80 to something.
85 to 92 was a B,
Yeah.
right? Yeah, it was.
Anything under that sucked.
All righty. Next. Make sure you can do a pie graph. I think this is where we left off, wasn't it?
Yeah.
Okay. So make sure you can read a bar chart and a pie graph. And I think we left off with, I gave you an amount of money, and I told you rent and gas and all that stuff, and you figured out 2 of them.
Yes.
Make sure you can do that. And that's multiplying the total they give you. And I made that up. How much money was it? $1,800?
Something like that.
Okay, I just made that up. In a test question or a homework question, they're going to give you an amount of money. Like or amount of employees. 5,000 employees, and 16 of them had a cold. 16% had a cold. 8% broke a leg. 12% didn't come to work just because they didn't want to, and that kind of stuff. And then you actually have to find out how many people that is out of the so many employees. So you just multiply the quantity times the percentage like we did the other day. So make sure you write that down. All right, so we left off on that. I'm not going to insult your intelligence by going over that, but hopefully it'll give us an example. A histogram is a bar chart. There's absolutely no mathematical difference between a histogram and a bar chart. I think they just made it up to make it sound sophisticated. There is a histogram or a bar chart, and there is a line chart. Make sure you know both of them. It's not a big deal. Instead of putting boxes, they put dots and then attach the dots together. Not a big deal. Okay, blah, blah, blah. Make a histogram. Okay, let's make a histogram based on this. Let's make a histogram. So the first thing you want to do is draw axes with an X and a Y. I can't, I was going to say, no, I can't draw, so I'll have to do the best I can with a straight line because they don't let me have a straight line maker in this one. So, and what is the highest score, or the highest frequency? 34, right? So 40 would be our highest number to go to, so I'm going to do by fives. 5, 10, 15, 20, 25, 30, 35, 40. 5, 10, 15, 20, 25, 30, 35, 40. All right, and I'm just going to make this A, B, C, D, A, B, C, D, E, F, G. Now you can write those, but I'm not going to do it because that takes too much time. So I'm going to put A here, B, C, D, E, F, G. And instead of doing A, B, C, D, you write 20 to 29 on the bottom, 30 to 39, but I'm not going to do that. All right, how many 20 to 29s do we have? 32. So I draw a bar chart to A. And I don't care if you do a histogram or bar chart because they're the same thing. I'm not going to sit here and insult your intelligence by telling you they're different. They're not. 34, a little bit above that one. 14. 2. 6. I may be a little bit off because I don't have lines. And 1 and 1. Everybody get it? That's pretty much it. And if you want to put them together and make a histogram, that's fine. I'm not going to, that's one of the things, you know, like some English teachers get irritated when you use the word ain't. Well, I get irritated calling a bar chart a histogram, and there's no difference. To me, that's ridiculous. They didn't draw a bar chart. Why didn't they draw a bar chart? Huh. Oh, there it is. There's a histogram. Difference between a histogram and a bar chart. Well, I was going to show you. There's a bar chart. There's a histogram. Is there any difference mathematically? No. I think somebody was sitting around one day and said, you know, we're going to be statisticians. We got to have these big falutin words to use because we don't have much math to talk about except for statistics. So we got to make up stuff. We'll call a bar chart, we'll call it a histogram. That's what I really think the histogram came from. There's a bar chart showing a lot of different data. And I'm not going to go into all that. And that's basically that section. What section was that?
5C.
5C?
Yes, sir.
So we should go to 5E next. Okay. Somebody check your outline. I think 5E is next, right? I got that outline handy?
5D.
Is it 5D? I thought we did 5A, C, and E. 5B?
Yeah.
Okay. I don't have the outline in front of me, but if y'all say 5D, yeah, graphs in the media. Now, remember when I talked about bias? And I said sometimes people do it intentionally? Well, sometimes people don't do it intentionally. Well, people just don't know any better. Let's say that I work at a newspaper or a magazine, and I'm the mathematician there at the place that I work, and I do these statistics, and I draw a picture, and I send it down to graphics. Does the graphics guy on the computer know anything about statistics? Not much. So he may take my picture that I've got drawn, and he may make it flamboyant and flashy and pretty, but he makes it inaccurate. Okay? Is that intentional? No. All right? So there's intentional bias, and then there's stuff that happens by accident. And you got to know when you're being taken. Okay? I'll show you what I mean here in just a minute. I'm not going to go through that. Stack plot, I'm not going to go through that. Here's a bar chart. It's just turned on its side. You don't have to write it down. It's just the way things are shown in the media. That's not test. I'm not going to test you on that. You just need to know how to read it. His master's degree is anywhere from $60,000 to $83,000 a year, and this is by gender. So women are, of course, naturally you see that women are not what, and that's the way we live. I disagree with it. I disagree with it wholeheartedly. Okay, but I don't know what you do to change it. I don't know why it's that way anyway. If a person, for instance, I know that I've got female colleagues that teach the same amount of classes I do. And I would hope they get the same amount of pay that I get because they do the same job that I do. So I don't really understand how this can come about. I think I know where. I don't think you see it with teachers like me and a female teacher. I don't think you see it with a male and a female nurse. I think you see it when you hit the executive ranks and when you hit these flamboyant type jobs like actresses and actors. I think that's where you see a lot of it. Okay? But as far, I really don't think a teacher, I think that's also why they keep it confidential. I have no idea what my colleagues make as far as the same teachers that, same math teachers, my colleagues. I don't know what they make. I think that's one of the reasons they keep it confidential. They probably pay everybody else more than me. I don't know. But, that's just a breakdown of how people are paid. All right? Who knows? I don't know how that works. I don't know. I'm for equal, as long as, and I don't see how you can measure the difference between the wisdom of a female and the wisdom of a male. I don't see how you can do that. So that's why I don't believe in this, but that's just me. And again, this is a bar chart showing the same thing. Can a bar chart be more clear than a line chart? Yes. In fact, this one is much more clear than this one. So you've got to pick your graphics carefully. All right? That's why pie charts are used so much when you're talking about economics. Pie charts and bar charts are used the most because they're most clear. Okay? You start getting into these line graphs, and there's a number one rule to presentations. Whenever you make a presentation, what grade level are you supposed to keep it on? 5th and 6th grade level. Because people that you're presenting to, they either are not going to be interested, or they're going to be interested, but they can't understand what you're talking about because you're the expert in the field, whatever you're presenting, and they don't know what your field, they don't know your field like you do. So you have to keep it on the 5th or 6th grade level as far as the slides, as far as the presentations. Okay? So using a flamboyant graph sometimes hurts you versus helps you as far as a presentation of statistics go. And that's what I just said. All this is what I just said. These can be awful, okay? These are some of the worst graphs to use in a presentation. They're called stack plots. I'd never have used them because when I look at them, I get what? Confused. And you don't want that. So this is one not to use. This is another one not to use. I'm not even going to look. You can look at it and you have no idea what's happening. And we'll get to the bias in just a minute. This is a good graph. Why is it a good graph? Because it shows all the United States. It gives you a good legend. And it says what the per person energy used by state. Gallons of OIL. I don't pronounce OIL. I spell it. Okay? OIL equivalent. So South Carolina, how much do we burn? We burn 2,000 to 3,000 gallons of OIL per year, I guess. I don't know. I guess per person, I don't know. I don't know what it says, per person energy use by state. Dang old Wyoming. Why does Wyoming and Alaska use so much? I guess it's dang old cold. I don't know.
That's what I was thinking, but all the other states around them are really
Well, it could be because they don't have very much population. Montana, there's not many people that live in Montana. Look at the populations under them. I don't know. I don't know if that's population. No, that's not population. That's gallons of OIL equivalent. So I don't know. There's all kinds of. But I can understand Alaska. Dang old Eskimos. Dang old cold up there. Dang old igloos. That confuses me. That makes my head hurt. Okay? But what they're showing you is the jet stream, pretty much, and how that you see the colder right here in Wyoming. So I would assume a bigger part of the Wyoming population lives on this side of Wyoming. Okay? Who knows? I don't know. Maybe they tell you. They tell the color-coded states that category of energy used per person are either warm states, blah, 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 or states, blah, 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 blah. The 80 degree contour passes through Florida. Duh.
When I was in Florida in the beginning of December, it got down to like 30 degrees.
Yep.
It was like the 2 days I was there.
Yep.
And it sucked.
This one can confuse you even more. Okay? So it shows you that in the last 10 or 20 year period, who put out the lowest carbon dioxide emissions? Who put out the lowest? Who put out the highest?
China.
And who's not really a big part of the climate change accord? China. They don't say anything about China. We pull out of it and we're the Antichrist. But China doesn't do anything and nobody says anything. China surpassed Russia in total emissions. That's because the Russians got into their system and broke it down and tore it up and told them who to vote for. Okay, now these are pictographs. And look at the top of the page. This you will be tested on. All right? Perceptual distortion. Why is this a perceptual distortion? Somebody tell me why. Look at the picture and tell me why it is distorted. It is not accurate. Why?
Dollar gets smaller.
Okay, you're getting there.
Is it inflation?
But as the year goes on, the dollar gets less.
Look at the dollar bill at the top. What is the relationship between 1980 and 1990? Wouldn't you say that it's cut down about half? Well, what does half the dollar look like? Well, let's take it and see. Let's take my handy dandy drawer. And let's just cut this dollar in half. Does everybody agree that that's about half? Yes or no?
Yeah.
It's about half. In fact, it's a little bit, I guess you could say it's half or a little bit more than half, which would be 0.63. Now let's take our handy dandy arrow and let's pull this down here. It's not going to let me. God bless it. Oh. So simple. But, okay, if you take that 1/2, I'm just going to try to draw it again. Does it look like and I hope I didn't even draw it the same way, did I? It's a little bit smaller, isn't it? Does that look about the same as this? Does this red line look about the same as that?
Yeah.
But what's wrong with the dollar they show?
It's like really small.
It's very small. That's a distortion. Okay? See, this, let's say this is 0.63. We said there's a little bit more than half, it looks like. Looks like this is smaller than this. But you bring 0.63 down here, and it looks like that, but the 0.63 they're showing is less than that. What about 0.4? Wouldn't you say that's probably 1/3 of a dollar? 0.4, is that about 1/3 maybe? 0.33 is the 1/3, right? What time is it? I hate these freaking classes. Anyway, 1/3 would be like, or 2/3, let's see, 1/3 would be like this. Would you agree?
Yeah.
Yeah.
Oh, that looks like. So does that look like 1/3 to y'all? No, it's distorted. All right, we're going to have to stop there. Would you make a note? We stopped this section. Well, then we got like 10 minutes each. All right, anyway, this is the best way to go because Pendleton says so. All right, I'm not going to take roll because it's too late. Y'all go ahead and get out of here, and I'll see y'all Friday, okay?
What about the homework?
Let me look at the homework for you right quick. If you'll stay, because somebody might explode if y'all don't leave soon, but if you'll stay, we'll look at it. Let me go ahead and cut the...
Sure, the one we did.